Hello from Austria. Welcome to the next Fronius webinar. The topic today is energy sector integration, or in other words, a future based on renewable energy. My name is Hans Pelzer. I'm your trainer today, and I will guide you through this next 45 minutes. What's on the agenda? First, I'd like to explain you a little bit about the definition and some basic information about this trend to more electrification, how to achieve high self-consumption rates. Then we look into e-mobility and into heating from the technical aspects and more in detail. And finally, some Fronius solutions in practice. Now, what's energy sector integration? The definition is the integration of the energy sectors electricity, mobility, and heating. And we all combine that into the electric supply network with full electrification. That's the definition. Basically, why do we need it? The target of the Paris Climate Conference in 2015 was that we want to limit the global warming at a maximum 1.5 to 2 degrees. To achieve this target, we need 100% CO2 neutral energy supply. And that's for all energy sectors, and the easiest way to do that is with the electrification of all these energy sectors. So how do we do it? There are 3 pillars, as you can see. Finally, first we need to have 100% renewable electrical energy. That's done with solar PV, wind power, hydropower, and also other power sources. So a full 100% renewable energy. Second pillar, we need energy storage. That's important because we don't have this energy available all time. So we need to have a storage. Can be battery storage, can be also the EVs as a storage, or power to gas, power to liquid, pumped storage stations, and heat storage. And then that's the energy supply, but then we need also the energy management. And under energy management, we understand intelligent system, smart system, load management to start consumers whenever we have enough energy, smart grid controls. All the energy suppliers need to be controlled by this system, and a smart and high efficient consumers as well. That's also important. And all of that, actually, we are already working in these segments. So we as Fronius, with our Vision 24-hour Suns, we believe in a future of 100% renewable energy, and we work on solar PV, we work on the battery solutions, we work on e-mobility solutions and heat storage. And on the energy management side, we have in all our inverters load management included, and also the smart grid features to be communicating with the grid as well. So this is our picture, how we see the future, how our vision. You see here different sources, energy suppliers, wind, solar, hydropower, and different batteries in small houses, as well as bigger commercial buildings. And all this is realistic, all this can be done. We'll work on that, and we need you as well to help us with this vision. If we see the projected world energy supply and demand, we have got a study from the University in Stanford and Berlin, where they tried to find out how we can transition from now to 2050 can be achieved to reach 100% renewable energy supply. At the moment we have about 90% fossil energy. So that's fuels, biofuels and nuclear. So only 10% is wind, solar and hydropower. Now, so that's the first step. We need to exchange these power stations by renewable energy. Then, on the other hand, if we go on full electrification, we can also reduce the energy demand by about 40%, because the conversion to from combustion to electricity is more efficient. So electrical consumers have got a higher efficiency, and with this higher efficiency as well, for example, if you think on EVs, they are also very efficient. We can reduce the energy demand by 40%, and finally we will end up in 2050 with more or less the same energy demand. And that's all now electricity. So from now we have a lot of combustion to full electrification. Now we already see this trend of electrification. End customers moving away from gas and oil to electricity. They make their hot water with now a hot water heat pump or electric hot water boiler. They produce their heating and cooling of the room with a heat pump or an air condition instead of gas, oil or coal heating. They use as well for cooking an electric stove, not a gas cooker. They use for mobility in the future more and more electric vehicles and go away from gasoline and diesel. So if we look now at the average power consumption of a household, of a 4-person household, we see that the total energy per year is more than half of that coming from heating. So that's an example from mid-Europe. So we need most of our energy for heating. And here, for example, with the gas heating, we need 15,000 kilowatt hours per year as an average. Then we need about 9,000, 1/3 for mobility for our this is now only one diesel car. And then we need for electricity an average about 5,000 kilowatt hours per year as well. So in total we have an energy consumption of 29,000 kilowatt hours per year. If we go to 100% electricity, so if we convert the energy from the gas heating to a heat pump with an OHMPilot I will show you later, is a device to make hot water, to produce hot water. We can reduce the energy down to 6,000 kilowatt hours for heating. Then as well for the mobility, we reduce the energy demand from 9,000 to 3,000. So an electric vehicle is about 3 times more efficient than a standard diesel car. The rest, the 5,000 kilowatt hours per year, stay the same, so they will not change probably. So that means we have a total energy consumption of only 14,000 kilowatt hours per year, which means energy savings of more than 50%. So that's the energy demand of the house. Consumption is decreasing with this more than 50%. It's not said about the price, the cost. The cost is something different because the cost of gas at the moment is quite cheap as well. Electricity is sometimes more expensive. So it's not, you cannot say that also the savings, the cost savings are same and the same value. What motivation do we have to change to higher electrification? On the one hand side, on the public interest, we see less cost for the grid infrastructure. We need only one system, one infrastructure, the electricity grid, so lower maintenance and so on. We have a higher high efficiency. Heat pumps, for example, are more efficient as well. EVs are more efficient, and we're reducing our emissions, our CO2 emissions with that, because we are, if it's based on renewable energy, we have no emissions. Then, on the other hand, for the end customer, more comfort. He can use smart home solutions to start all these consumers, these loads. He can increase his independency away from gas and oil imports and produce his own power with the PV system. Then higher safety, no gas or oil storage in the house. Lower maintenance. The hot water generation, for example, has less maintenance, and less cost for a PV system because of lower module prices, PV module prices. So the PV system price is going down year by year. So with that, of course, we see that more and more people interesting to do that. Now I'd like to show you the Fronius solutions. First, the working steps, how we come from a consumer to a prosumer, so a person producing its own energy and using its own energy. We're starting, that's our recommendation, with a PV system, Fronius inverter, with a Fronius smart meter, and we do the analysis with that of the consumption of this building. So after a few months, weeks, we can see what consumers are running, what consumers running at what time, at what power level, and with that analysis we define a load, a big load, for example a hot water boiler or heat pump or an EV, and we start that with our load management from the PV inverter to start these consumers at the moment when we have surplus energy. And then we have, of course, still some rest energy available, and this will be used for hot water storage with the Fronius OnPilot. So we're producing hot water with this energy, or we store the energy in a battery, in our Fronius solar battery, for example. What self-consumption rates and what self-sufficiency is possible with that? On a 4-person household, again, 5,000 kilowatt hours per year consumption. If we have a 5 kilowatt peak PV system, we can increase our self-consumption, or usually our self-consumption is only at around 20 to 30%. Also the self-sufficiency is around the same level. If we do energy management, load management, we can increase the self-consumption up to 40-50%. For example, with a heat pump integration or an EV integration. Also self-sufficiency is then increasing. Another possibility to increase your self-consumption rate is to use battery storage. So for example, here with a 5 kilowatt hour battery, we increase the self-consumption up to 60-70%, and the self-sufficiency is also increasing up to a level of around 60%. Or the other possibility is the Fronius OnPilot. We produce hot water. We have a 500-liter hot water tank. The OnPilot is producing, we are heating road hot water at the moment when there is power available, and with that we increase our self-consumption to levels up more than 70%, up to 80% self-consumption rate. The self-sufficiency, on the other hand, is decreasing because we have quite high energy consumption now. So total consumption per year about 8,000 kilowatt hours per year now. So with that, we would need probably a bit more, bigger PV system on the roof to cover this energy and to also increase the self-sufficiency. How does it look like? If we look on a day curve, so this is the production curve, the gray curve, the PV yield. So the consumers, the dark gray areas here are the consumers starting in the morning and also some on the evening. So they are out of the production curve, and with that we see that the self-consumption rate is quite low, only at about 20% on that day. So most of the energy will be fed into the grid. So what can we do? We, for example, have an EV which is available in the afternoon. We start the charging process of this EV in the afternoon. So for example, here from 12:30 to 6:30, and we use a lot of our energy on this sunny day from our PV system. With that, we increase our self-consumption rate up to 50% already. Another possibility then, a next step would be then a combination with the Fronius on-pilot. So we use the additional power, this surplus power, which is now the red part of this curve, to produce hot water with the Fronius on-pilot. So this is about 11 kilowatt hours the rest of this day, and with that we can produce 200 liter hot water with 60 degrees. So, and the nice thing about that is we increase our self-consumption rate on that day to 100%. So we use all our energy in this building. Similar additional possibility is with load management and battery. So all the surplus energy is now used in the battery. So we charge our battery with this power. For example, here we have a 9.6 kilowatt hour battery. We charge the battery on that day. So we nearly can use as well all the rest energy, this 11 kilowatt. So that's just a small rest at the end of the day, what we need to feed into the grid. But most of the power is used as well. Our self-consumption rate is 95%. And then we use, here the big advantage, use the energy at nighttime. So for our consumers at nighttime, we can use the battery as well. Probably can charge the EV once again in the evening or at night to get more of our power to the EV or to our consumers. So this was the advantages or the solutions for the residential solution. Now, two more examples for commercial solutions. Space cooling is a very good, nice topic as well. We have a commercial office building, 1,500 square meter, for example. Here, this is an example with a 50 kilowatt peak PV system and air condition. So there's no communication between inverter and air condition, but still the power of this air condition follows very nicely the production curve. So whenever we have a hot day, a sunny day, we need more air condition, so more power for the air condition. This moment 30 kilowatt, for example, and the afternoon about 35 kilowatt. All this power can be used from the PV system, and we use a lot from our PV system. Just see self-consumption rate 90-80% in this example as well on that day. Then another commercial solution is an EV charging. So we have a company with 10 EVs, for example, and they have 10 wallboxes where they are connected. They are going from for a small trip every hour to another office, for example, and coming back again will be charged again. So it's a continuous charging process during the daytime as well in this moment. And we see as well here we can use a lot of our PV power with a 120 kilowatt peak PV system. We charge our electric vehicles up to 100 kilometer range per day per car. So that's also quite nice to see how this would work and increase the self-consumption. Now I'd like to go into detail about e-mobility, some basic information and as well the solutions, how to charge an EV from your PV system. There are generally two possibilities on the residential side. We use our standard socket in the garage for single phase, for example, the CE Cara socket recommended, especially if you go more than 2.3 kilowatt, and three-phase, the standard CE socket, three-phase socket in the garage is needed. And then we can adjust on the charging cable the power, for example, a power of single phase 3.6 kilowatt with 16 amps, and with three-phase, for example, 4 kilowatt on three-phase, and we should lower the charging power as well. So we need to set the power on the cable to a lower level because we want to use our PV power, and usually in a standard residential building we don't have too much PV power, so probably maximum 8 kilowatt peak or something, 5 to 8 kilowatt peak, depending on the roof space of course, but usually that's a kind of limitation. So we set our current to a lower level and charge our car with the power from a PV system at a slow charging, as well. Or another possibility, of course, is charging from a WALLBOX. So they are made for these solutions as well. They give a bit more comfort, so they can also be used on single phase or three phase, and you have some advantages to control the energy as well. From that I will show you on the next slide. On the other hand, of course, this is a high power charging process, for example 22 kilowatt, and if you use a WALLBOX, they will always charge at high power, and you then are probably not using too much of your PV power. So it's probably recommended with a PV system, a smaller PV system, to limit the charging power. What you can easily do with these charging cables, the first two on top. What solutions can be offered? First, the EV charge socket controlled by the digital I/O from the Fronius data manager, which is inbuilt in all our snap inverters. This is for a smaller PV system below 10 kilowatt peak. We have a 12 volt relay which is started from the I/O from the inverter, and this relay will start the charging power on the socket, so single phase or three phase socket. And what we additionally do in this case, we start the charging process during daytime. Whenever the car is available during daytime, you get your PV power to charge your electric vehicle. But additionally, we have a night charge programmed in the inverter, where we can also charge additionally from, for example, midnight till 6 o'clock morning. So with that, we make sure that you get your range requirement on the next day, and even on a day where you have arrived later in the evening or a very dark, cloudy day, you are sure to have your car charged in the morning. Additionally, probably recommended a manual switch to where the customer can start the charging process during daytime immediately whenever he needs a fast charging, immediate fast charging. The other possibility is the stepless charging via LOXONE and the WALLBOX. This is more a commercial solution, so here we recommend a bigger PV system, so more than 8 kilowatt peak, for example. And here we can control the charging power from this LOXONE home server to the WALLBOX, so they can really regulate the power according to the surplus energy. And this is of course nice, because with that you get more, you can use more of your PV power during daytime, because the power is regulated according to the PV output. Some other advantages you can activate that via an app, so the WALLBOX can be started, or the LOXONE home server can be started also via an app, so you have all possibilities with that. Yeah, these are the two solutions. Then for a heating or hot water service, we have another few solutions which I would like to show. So first, the electric heating devices, heat pump and so on, how to control that. And then the OHMIC heating devices with the Fronius OnPilot. Standard heat pumps, for example, or air condition, like shown here, are like the heat pump, are very efficient. They have using only for example, 1 kilowatt hour electrical energy to produce 4 kilowatt hour heat. So they are very, very efficient. Also the hot water heat pumps, air conditioners are not so high efficient, but they're also more efficient than a standard heating source. What's important here, these heat sources need to be controlled by the Fronius energy management, by our load management. What we are doing is here, we're also using this digital I/O with 12 volt relay. We're starting the smart grid ready heat pump. So it must be a smart grid ready heat pump. Please have a look on the label of your heat pump, and then you have usually an input with 2 cables, so a contact where you get the increased temperature mode. So whenever you activate that, the heat pump will increase the temperature. For example, the hot water temperature from 40 degrees to 55 degrees. After that, if the hot water is ready, so the hot water tank is full with 55 degrees, you can also use this contact for heating or cooling. So some of the heat pumps can also cool down the house, and then you can, after the hot water generation, use the energy as well in summertime for cooling, for example, or in springtime for heating. So this will be done automatically from the heat pump. The heat pump can regulate that according to the outside ambient temperature or to the indoor temperature. So this is all as well integrated in our inverters, these output, and make sure that your heat pump has got this smart grid ready label, and then you can also use your PV power for your heat pump. Then secondly, we have our OHMIC heating devices, so heating devices which can be controlled from our Fronius OnPilot. This is also, the name is coming from that. So what are OHMIC heating systems? For example, electric underfloor heating. So it's just a cable in the floor which is heating the floor. Then, for example, as well, infrared panels, which are mounted, for example, on the wall, where you can also get your room heating, and the heating rod in a boiler. So here we produce hot water in a boiler, and we just regulate the power of this heating rod with the surplus energy. Yes, and that's done with the Fronius OnPilot. The Fronius OnPilot is increasing the self-consumption by using stepless control of heat sources. So we are steplessly controlling the surplus energy for these heat sources. Applications: hot water generation with the heating rod, infrared heating, towel dryer, or floor heating, electric floor heating, as shown before. How is it working? What components do you need? You need the Fronius inverter with Data Manager 2, a smart meter which is measuring the surplus energy, and then the communication from the inverter to the Fronius on-pilot to give him exactly now, for example, this 500 watt surplus energy to the heating rod. So then you have no power, no feed-in power, so all power will be used in the building for the consumers and on the heating rod to produce hot water. Other devices you need, so the data manager 2 in the Fronius inverter, the smart meter, and the Fronius on-pilot. A temperature sensor is optional, possible as well, but not needed. And available will this product be as of Q4 2017, and we will show this product as well on the Intersolar 2017 in 2 weeks. So if you are interested, please come and have a look on our booth. What is the result of this on-pilot installation? So before the installation, we had to have a self-consumption rate of only 30%, below 30%. Actually here, for example, in June. After installation in July, the self-consumption increased to 65% in July. In August it was even more, and in September and all the winter months it's up to 100% self-consumption, because the on-pilot is also using the energy on the days where you have low irradiation, and then you use it full. You can use more, actually all your power on that day. On a sunny day it's sometimes, or a summer day, it's even a bit more difficult to use all the energy. Now what open interface do we offer, or what third-party communication do we offer on our inverters? We have this Data Manager 2 card integrated in the inverters on the SIMO hybrid, the hybrid manager. So this is the card which you can see when you look on the inverter. So on the bottom of the inverter you see these connectors here. So on one hand side we have our Modbus RTU RS485 to connect smart meter, solar battery, and on-pilot. On the other hand, the LAN, or the Ethernet connection, can be used for the Modbus TCP or the Solar API protocol to read out data for a third-party device. For example, home automation device or a third-party monitoring device. So here these devices can read out the data from the inverter, can read out surplus data or PV production data, whatever. Then we have as well digital IOs here on this orange plug in the middle. So there are 4 digital IOs and 6 inputs. The digital IO, so this one output, the digital IO1 is used for this load management. So there's at the moment only one for load management. With that you start your consumers, for example, as told you before, the heat pump, to bring that to the overheating, to the increased temperature mode. Yeah, these are the interfaces, and then we have also a push service, a data to a server where we send the data from our server to another server. This is also possible for monitoring. How does it look like with the LOXONE home automation system? So the LOXONE system is already prepared for the Fronius inverter. So we have already existing data in that software. What all you need to do is to connect a server via cable from the LAN cable from the data manager to the LOXONE, and our Fronius smart meter via Modbus RTU, and then you can use all features from the LOXONE home server, for example here to control an EV charging process. So the EV, the WALLBOX, will get an enable signal and charging power value, how the power, what power is available surplus power is available to charge the car accordingly. Yeah, then a short summary again. All these extensions which I have explained are very quick amortized, so you get a fast return of your investment. For example, the EV charging socket via load management within 2 to 4 years, and all you need is only the smart meter and the relay. As well, the heat pump similar, e-scooter charging similar, and the Fronius on-pilot for hot water generation. Here you need the smart meter and the on-pilot. Within here you have a little bit longer return of investment, so between 4 and 10 years is here the ROI. All the calculations are based on the energy tariff of 15 cents per kilowatt hour. Yeah, if you're interested in more information, we have we'll send you the presentation after or tomorrow morning, and as well the video about that. You can also use use our other webinars. So if you go on our webpage, or if you send us an email about EV charging, about heat pump control, or the Fronius on-pilot. So all of that will also be shown on the Intersolar in Munich, which starts on the 31st of May till 2nd of June in Munich. So don't forget about that date. And we have also other videos and flyers on our webpage. So please come and try. If you need any information, have a look there, or let us know if you need anything else. Good. Then that's all from my side. I would like to thank you very much for your participation. We would like to stay with you and answer your questions. Just have a look, or if there are any questions. So far, all questions are answered. I would like to as well thank you very much for your participation. We stay with you for a while. I just switch off my microphone now. But we stay with you and answer your questions. Thank you very much for your participation, and I wish you a good evening, a nice day. Thank you very much. Goodbye. Bye-bye.